Hey everybody, welcome back to Young Engineers of Today. Um, Miss Saunders here. I just have a cold, so I sound a little bit different. No, I'm sorry, I can't keep that up. Just half-hearted attempt at messing with you. As I'm sure you've already heard, Miss Saunders picked up a new job, so she is not able to continue doing this class, at least for the foreseeable future. In the meantime, my name is Mr. DeToy. You can call me Thomas or Mr. DeToy. Doesn't really matter. I'm okay with either. But I'm going to be teaching you from here on out. Hey, Sam. I'm going to be teaching you from here on out. Or do you prefer Sam or Samuel, just so I know for the future? Because sometimes I prefer people call me Thomas as opposed to Tom. Either one is fine? Okay. I knew a Sam from a couple semesters ago, so nice to meet you too. Hopefully, you guys won't get too annoyed by my lame jokes and my terrible drawings. I will do what I can to make this as interesting as possible, especially considering the fact that a lot of times it's just me talking at you for an hour. I'm sure. I'm glad you guys enjoy lame jokes. I don't know exactly. I don't know if you understand exactly how lame we're talking here, though. So reserve your judgment until a few of them come out. But I know you guys are probably. I know Miss Saunders does a wonderful job, so I know that's unfortunate. And I know she really enjoyed teaching you guys, and she's pretty bummed out that she's not able to continue. But I'll do my best to keep things interesting and fun, and well, at the very least, uh, informative and colorful. Let's just say that. With that in mind, as I understand it, you guys were working on processing, which is yeah, colorful. Said it. I meant it. Um, which, as I understand it, was a. I actually just introduced myself to processing in the last couple of days. It seems pretty interesting. Yeah, it's kind of like JavaScript. It's kind of like JavaScript. It's got a little bit of kind of like a C flavoring kind of going on there. Um, so if you get familiar with processing, actually, you can kind of get familiarized with the syntax of C. Um, it feels very similar. Uh, C and C++ and C Sharp and all those wonderful programming languages that I personally am uh, partial to. Um, but yeah, that's what we were continuing on. We were going to draw a bunch of stuff on the screen today. Um, by the screen, I mean the processing screen. And then we were going to do some more stuff with that. And then I think there was like one more processing lesson, and then we're going to move on to different, perhaps greener pastures, depending upon your particular uh, preferences. If you're not a huge fan of programming, then the next thing we do could be more interesting. If you are, well, hopefully the next thing will be cool too. I personally like programming. I'm a computer science major, so I've dealt with a lot of programming, and I enjoy it. Um, I think something broke my brain, so now it's a fun thing to think about. It's nothing wrong with you if you like programming. But at any rate, well, first of all, how was everyone's weekend? I'm glad to hear that you love it. Good, good. Do anything interesting? Oh yeah, no problem. Ooh, got some skiing. We also got some nope. Got a guinea pig. Nice. What'd you name it? Clovis. Oh, we got somebody who played the Division and a Young Engineers meeting in Charlotte. Well, I mean, it could be. You could be watching some really interesting shows on TV. So, you know, mountain biking, nice. Now, don't laugh. I played a lot of Dungeons and Dragons over the weekend. I have a session that I'm in, and I just got another session that I'm running. So, yeah, it was an interesting weekend. Oh, you had a basketball game. How'd you guys do? Dungeons and Dragons. Yep. I'm actually very partial to it. I didn't actually start playing it until high school, and I love it. Oh, nice. Hey, congratulations. 40 to 30 something. It was close, so it was a little bit dramatic, but at the same time, you managed to pull out the win. That's pretty awesome. Congratulations. Tend to make my own game more than play games. See, there you go. That very first presentation we had where it was like, do you like making games more than playing them? That was specifically for you. Very hungry. Well, hopefully you've eaten something in the last couple of days, because if that was your weekend, that doesn't sound like a great weekend. Yeah. Yeah, I know the feeling. Word to the wise, once you start paying for your own food, it really helps to have enough money too, and also pay rent and things like that. What games do I play? Oh, geez. I just started playing Awesome Knots recently. I've been playing a lot of XCOM 2. Um, there's a game I play all to get too much of called Titanfall. Um, yeah, you know, just random stuff. Destiny. I played a little bit of Destiny. I couldn't really get into it. It was. I mean, I didn't own the. I know. I'm sorry. I didn't own the PS4 first of all, but there's a lot of like grinding and stuff like that involved in Destiny that I just Oh, Battlefront. I played a little bit of Battlefront. I'm a huge fan of Star Wars, so that helps out. Um, and Dice, as far as like sound engineering and stuff like that is concerned, is a pretty is a very solid company. They made a very pretty game that sounds very good, and it's Star Wars. I just wish they had more content, but oh well, we can't have everything. All right, so as I understand it, you guys made lines in processing. Does that look familiar? Yes. Okay, good. Good, good. Oh, you ran into some issues with that? Is it was it a coding issue or is processing giving you a hard time? Oh, you don't have the code. Oh, okay. Well, the next bit of code we're going to do is going to involve the same process in order to make these lines. So when we go over it today, you'll be able to get that code. So no worries. I'll go ahead and put that code in after I get it done and everything like that. We'll go over it together. Did you guys talk about, um, struggle? Weird. So the 64-bit one didn't work at first, and the 32 one hasn't worked at all. That is definitely Einstein. There is no way. Um, there's no way you can miss that mustache and hair. That's Einstein through and through. The 32 worked a little. Oh, okay. Yeah, that's a little strange. Because like in general, um, yeah, the 32 should be the safer option of the two. But yeah, it might have just been I don't know. Let's think about that. Well, anyway, oh, it deleted all your work. Okay, that's pretty bad. That's pretty bad. Well, when we go over the code today, I'll either yeah, we'll get you up and running again. So I know you guys probably already went over this, but I want to go over this point again because it's actually a very important point as far as creating and you know, inventing and developing and all these sorts of highfalutin engineering concepts are concerned. Innovation does not come without a struggle, at least some struggle. And let's be honest here, oftentimes a lot of struggle. There's a lot of, you have this wonderful, fantastic, just amazing idea and you go out and you develop it or create it or whatever, and it doesn't work the first time around. It just doesn't. Then, at that point you don't go like, oh, I don't know, I'm no good at this. I should I should just give up. That's not the idea behind this. And if everybody gave up on their first try, I mean, we'd probably still be um, drawn inside of caves and afraid of thunder. It was a bit odd, but I'm perfect. I know, I know. So you know what? You don't have to listen to this because it doesn't apply to you. But for everybody who's a normal human being, you know, things aren't gonna. Ooh, that was a bit nihilist. Um, how about life is about improving upon perfection then? Because you can always improve upon perfection, despite what you might think. I know, right? Um, things aren't always going to go well the first time around. They're probably not going to go well the second time around, or the third time around, or the fourth time around. But it's all about improving upon your design each time, learning from what went wrong the last time, figuring out how maybe to fix that. If it did, fantastic. If it didn't, that's okay. Try something else. A lot of times, if you fix one thing, another thing will break. It's just kind of the nature of the beast. Um, so it's all about improving upon your design, your idea, whatever it might be, and working through those difficult periods where you feel like, oh man, like I really don't know if I can get this done. I really don't know if I can make this, or I really don't know if it's possible, or whatever. Working through those and figuring some other solution out. Working with other people, trying to get other ideas, giving yourself some notion of forward progress and working through those walls in order to come up with something. Edison, he didn't invent the light bulb on first try. Uh, I don't know the exact story, but it's entirely possible that he set a fire on his first try. It was like, here's the light bulb, and he turned it on, and then there was fire, which is not something you want to have happen with the light bulb. Maybe the second time he tried it, he flicked the switch and nothing happened. Third time he flicked the switch and the light bulb exploded. It's always a process where you've got to pick yourself up from your last attempt and push through and get it right on the next time. Einstein didn't come up with this famous equation on the first try. He wrote something down and he went, well, that doesn't make any sense. And so he worked through it and tried to figure out what the issues were with it. Maybe he made a second one and he was like, oh, okay, well, at this rate, the universe should explode 15 times a second. And he was like, that doesn't really make any sense. So he, kept working at it. Eventually, he came to his theories of relativity, all of them, and his general theory of relativity. Now, Einstein was a really, really smart guy. Einstein took some really awesome pictures and shorts, but he wasn't quite perfect. He made mistakes just like we did. Well, except for maybe, you, because I know you're perfect, uh, apparently. But everybody's gone through these processes. Everybody's had this sort of struggle. We always see the results of it. Now you're questioning Einstein now, or are you questioning me? Because I mean, I can be wrong a lot of the time. I try not to be, and I have these handy slides to help me out, and I spend my time learning this stuff too, so that I'm not wrong as often. But it'll happen. It'll happen. So I know I'm not. I'm really not. I'm sitting here with my mug of coffee and my glass of water, just trying to not make life fall apart around me. I'm far from perfect. Um, we oftentimes see the results of these, these struggles. We see the light bulb and we go, well, my coffee is pretty good. Yeah, it's not quite perfect. Yeah, that did seem kind of bleak, didn't it? Okay, it's really not that bad. It was just it was a it was a nice sound bite that came out in the moment. Um, Having a cat helps. Got a cat asleep next to me. But we see the results of these things. We see a light bulb, and even now, even today, the light bulbs are being improved upon with all kinds of different iterations. CFLs and LEDs, and longer lasting and use less power for the amount of brightness that they give out and things like that. Like they're constantly being improved upon. But you look at it and you go, wow, okay, so like somebody just had this like flash of insight and they invented a light bulb. This somebody, in this case being Edison. He was just like, well, what if we used a wire to make light? That's true. They are better, but they're not perfect. They have issues of their own. Um, so we think of it like this guy was incredibly smart in order to be able, yeah, that's a big issue, in order to be able to do this, but we don't see all of the, and of course he was smart, but we don't see all of the struggle he went through in order to develop it. We see, gravitational waves, like you guys just had that presentation last Wednesday that proves that yet again Einstein was right. Theory of relativity is coming on 100 years old now, and we're still going like, hey, he was right, and we just have the technology now in order to figure out that he was right, to prove that he was right. Oh, hello. um, so but yeah, we don't see all the struggle that he went through on that. So yeah, if you guys are having like, you guys are running into roadblocks with coding or developing or anything like that, just understand it's a perfectly normal part of the process. It's it's going to happen. And really, the thing that makes development a success or designing a success or whatever it may be is pushing through those issues, figuring out solutions to them, workarounds, whatever the case may be, and creating something that at least can be improved upon but does what you want it to do. And this is a picture of the Centennial Light, as I'm sure you guys saw last Monday, the world's longest burning light bulb, which is in a fire department in California. It's been burning for 113 years, which is pretty impressive. This connection has not been broken. This wire has not been broken. It is not burnt out. That's pretty impressive. Uh, by the same token, we do have houses that are like, 150 years old or whatever, and they have electricity. It could just be that it's made out of a thicker gauge wire, and between the thickness of the wire, the material it's made out of, and the amount of electricity going through it, it's not actually heated that up enough in order to create like to break the metal, to burn the metal to the point of breaking, and sever that connection. So it's still got a complete circuit in there. Um, it could be the conditions inside the bulb. It could be any number of things. We'll check that out later, Gavin. So, yeah, let me go ahead and get started on this code. And we'll do this as a little bit of review too. So, you guys went over, I assume, like curly brackets and things like that. We'll do. Okay. And why they exist. How about stuff like void setup and void draw, like what those mean? Well, I've had a lot of practice, but thank you. Okay, good. So you guys know, sort of the idea behind these. The word for them, what have you guys been calling them? Because these types of things, like these void setups and these void draws, they tend to have a name. Have you guys been calling them anything in particular, or have you just been referring to them by like void setup and void draw? Loops. Okay. Yeah. These are definitely a form of loops. All right. Well, we'll continue referring to them as loops then. Now, in general, um, these do loop. Like void draw, as you guys I'm sure already know, will draw once a cycle. Every time the CPU calls again to do more calculations from this program, uh, the program will send void draw to it in order for it to calculate that. So yes, this is a loop because it loops. You might see these given different names in the future, though, either methods or functions, depending on which road you go down as far as programming is concerned. Um, Forever loops, right? Because like Scratch, because it's a loop that runs forever, so it's a forever loop. Yeah. Um, I might refer to them as methods or functions in the future, um, because that's what I'm used to. So just so you guys know, whenever I say methods or functions, I'm referring to the forever loops, um, or this void setup. All right. So yeah, just so you know, because loops can also be, there are like for loops and while loops and things like that, which are not like these big, which are contained within these functions. So sometimes I'll say that for clarity's sake, but I don't want to muddle anything up necessarily. So I'll try and keep the same nomenclature. So so we'll turn this into a mini quiz. What does the size do? Over 9,000. Yeah, it makes the size of the box. It makes the size of the window that we see our processing stuff in. So like this is 1,000 pixels by 1,000 pixels. It doesn't really look like it, but it's probably an optical illusion because of my monitor's resolution. But anyway, this should be just in this gray part in here. It should be 1,000 pixels by 1,000 pixels. So that's what that is about. It's a size in pixels. Now stroke. Does anybody know what stroke does? Exactly. Makes the thickness of the line. It changes the thickness of the line and things that you draw and everything like that. Yeah. And then how about backgrounds? My fingers are failing me. Exactly. What do the three numbers mean then? Exactly. Yeah, so this determines the background color, and then the three numbers represent the amount of red, the amount of green, and the amount of blue, anywhere from 0 to 255. Yeah, 255. Now, I could go into a whole computer science explanation as to why 255 is the largest number that you can use, but in the interest of making some progress on the lesson today, let's go ahead and move on down to void draw. So line, as you might imagine, gives you the size of the line. You've got a length, or rather, you've got a starting point. So 500, 500 means that it's true. It can also use hexadecimal. Whoops. Let me just go ahead and do this. So if you remember, our window is 1,000 by 1,000, right? So the first two values, 500 and 500, are starting x and y. So that means it's going to start in the center. The second two values, mouse x and mouse y, those are variables, right? Those hold the position of the mouse cursor in the x and y coordinates. So what this is doing is this giving us the end point of that line. So it's always going to start in the center, and then it's going to end on the mouse position, and it's going to draw that line once per cycle. Again, once per cycle. Now the cycles don't run as fast on processing as they do on the computer, which is why we have these sort of breaks in between the line, because the cursor can actually move faster than processing can sort of render. Sure, I'm always down for something in binary. Is it a ASCII binary, or are you ah, ah, ah. For those who were curious, if you want to type something in binary, that's how you do it. Thanks, Cameron. Anyway, it's going to start in the center, and it's going to draw it to the mouse position. You broke processing once? Congratulations! You are a programmer. That is pretty much like a rite of passage for programmers, is to break whatever they're programming in. So if that happened, oh Lord, yeah, that probably freaked out. So what exactly am I typing here? I'm sure it does, because it's trying to, yeah. It's going to the print to the console. Yeah, exactly, exactly. So the print just prints it out directly to the console. And then we've got this mouse x equals the stuff in the parentheses, or the stuff in double quotes, is going to print that exactly out, character by character. So it's going to print mouse with a capital M, a space, a capital X, an equal sign, and another space. And then the next line we have print. So this basically is just going to append, or if you want to use fancy programming terms, concatenate. It's going to add this mouse x value, whatever's inside of mouse x, to the end of it. It's going to do the same thing down here with 5 spaces and then mouse y, and then it's going to print mouse y. But notice this one's print line, which means that after it's done printing it, it's going to print the next stuff on the next line. Concatenate, yeah. With an E instead of an I. Oh, good Lord. 5 times a second. Yeah, I was running into an issue with something I was coding. I was trying to lock. It was a prototype for a game, and I was trying to lock it to 60 frames per second. The problem was when it was going slower, like it would basically take the difference between how fast it was going and how fast I wanted it to go. So it could be going 144 frames a second, and I wanted to go 60 frames a second. It would wait the amount of time left over in order to ensure that it was 60 seconds. The problem was when it was going slower than 60 frames per second, the time left to wait would turn negative, and so my entire computer would lock up waiting for that negative period of time, which, as far as computers are concerned, would have eventually happened, but it would have been years from now. Actually, it may not have. It may be unsigned, now that I think about it. Anyway, computer science stuff, just computer science things. Yeah, so, I'd have to Control-Alt-Delete and restart my computer, and it took me forever to figure out what exactly was going on. Uh-oh, ran into an issue? What do we got here? Your line. Your line is the issue. I can tell you exactly what's going on, or based on what we've been talking about, maybe you can take a stab at it. Oh, is it saying there's an issue with mouse Y? Oh, I see what you got going on there. Yeah, I see the issue with mouse Y. Check out that second part. Where's your second double quote for mouse Y? Basically, that's how I should put it. But I will say you should take another look at your command to print out the line. Nah, it's years and years of finding bugs in my own code. Trust me, that's all it is. Take a look at your line command and see if there's anything that can be done about that too, because it's going to look kind of funky when you run it. It should run just fine, but it'll look kind of funky. I believe it should. I could be wrong. There's that realization. All right, so this is the code that, as far as I know, that you guys got from last Monday. Yeah, that's always a great feeling too, because you're like, I can't figure out why this doesn't work, and then you go look at it years later with like knowledge, and you go, oh yeah, like I know exactly what I did wrong there. Okay, I'll just go ahead and fix this, and then it works fine. Nothing wrong with keeping old code. I've got code from years ago just kind of sitting on this computer. Now, granted, this computer's only 2 years old, so it's not that old. But 2 years is still, you can still say years, technically speaking. Anyway, this is as far as you guys got, as far as the code is concerned, from last Monday, if I am understanding this correctly. So you were able to do this liney bit and get these lines and have it do the thing. That's true. I've had it for years. 1/2 of them. Nice. So yeah, that should have been the code that was lost from your processing breaking, dumping all of the spaghetti out of its pockets. All right. Pank. So pank. All right, so we're going to do another type of function now. We're going to add in this new function. And it's going to do another thing. Oh, yeah, sure. Yeah, let me just go ahead and whoop, 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 whoop. Done. All right, so now I didn't say I was the one who was going to make it pink. And also, don't judge. Everybody likes their colors. Some people really like pink. Some people really like pink, and there's nothing wrong with that. Just because I'm not a fan of pink. Anyway, I'm getting sidetracked here. What do you guys think this new function is going to do, or this new loop is going to do? No, not. I'm actually going to circle it with the pen here. That one right there. Yeah, no problem. This is the new bit of code that is added to the program that you guys have so far. There's this other writing which already exists on it, and I have no idea where it came from. When you click your mouse, something will happen. Something will happen. What do you think's going to happen? But so far, so good. When you click the mouse, something will happen. Exactly. It will change the background color. So excited that it's pink. The rest of the lines will disappear. All right, I like this. Yeah, yeah, yeah. Well, like with a name like Gavin, yeah, I kind of figured. Um, that was my assumption. Um, Fair point. That's a fair point. You know that Ashley is also a guy's name too. It's technically it's a name that could be either a guy's name or a girl's name. Yeah, yeah. I can understand that. That at this age, when you get older, it won't really matter. But yeah, yeah. So yeah, the rest of the lines will disappear. That's actually exactly what's going to happen. You'll notice that this background function up here, whoa, that was meant to be me underlining it, not drawing a line through it. And then this background function down here, they both have the same RGB values. Yeah, I'm sure it will. Given enough time, people grow up. They both have the same RGB values, 192, 64, and 0, to create this nice sort of baby food orange color that we've got going on. So when the mouse is clicked, what actually happens is, yeah, well, for you, it's pang. What actually happens is it redraws the background over the screen that we have. Because there really isn't a way to erase stuff in processing. What you do is you redraw over it, essentially. That's how we get rid of these lines. So let's go ahead and add this bit in. Oh, it's lowercase m. Boom. So with that added in, I can click the mouse, and there's always going to be one line there because it redraws as soon as the new background is placed down, so it's going to draw that line. But on the other hand, we can erase all of these lines by doing that. So we can go like, wow, and then hit that. It's not working. Okay. Thank you. Be awesome under void draw. Yeah, sure. Done. Is the screen refresh not working, Liam? Perfect. All right. Why don't you copy paste that bit of code so we can see what exactly is going on? Yeah, the thing's going to say Caroline Saunders because this is technically her account, um, and she's going to use it in the future. So, like I said, the Saunders is here. She just has a bit of a cold, and her voice sounds different, and she also refers to herself in the third person. So many hacks. Aha! I see an issue. Liam, on your void mouse pressed function, or loop, you're missing an E on mouse. Somebody's really excited about that pink. How good it happens. Oh, pank. Sorry. Pank. Now, you'll notice, okay, so this is an interesting point. I'll get rid of the E on mouse and then go ahead and run it. Now, the program will run, but the screen won't refresh on click. but it's not giving me any error messages or anything like that. No problems at all. Like, it doesn't understand that I was trying to put mouse with an E there. Well, there's this really important life lesson as far as your interaction with computers now and in the future is concerned. And I'm sure, you know, that Miss Saunders brought this up to you guys at some point. Yep, exactly. That is the one. Computers are dumb. Computers don't like to assume anything at all. So as far as this mouse pressed without an E is concerned, the computer doesn't go, oh, he tried to say, you know, or she tried to say mouse pressed like this. It just goes, oh, hey, they made a new function and it's called mouse pressed. All right, cool. I don't know what's going to happen, but all right. So what's happened there is you've created a new type of function or forever loop that just never actually occurs. Because you can name these things whatever you want, as long as it's not, you know, these names. You can name them almost whatever you want. I could name this void Bob, and that would be my new function or my new loop. And that's perfectly okay. So if you do this, it's just going to assume that it's a new type of function. Whereas if you do this, that's a function that exists within the processing code and understands, and processing understands that it runs whenever you press down the mouse. It's muffin time, fantastic. And what do you got here for me, Cameron? That is some beautiful code. So it just has text that gradually turns to the color of the, oh yeah, it looks like it just disappears. And then it says that was cool. Nice. Nice. Yeah, no problem. I mean, I'm glad to see you coding. Make it a random color when you click. Actually, that's an excellent question because I'm not sure about random number seeds in processing. I'm sure that's a thing. Well, we can make it a variable, definitely. But we have to change x somehow. That's the thing. Oh, is that how you do it? Okay. I'm sure that can be arranged somehow. All right, let's finish up this code real quick, and then we'll talk about setting it to a random color each time. You know what? Yeah, we'll do this first. Okay. So you guys are pretty familiar with if statements, right? Like you've seen those before and all that kind of stuff. Maybe yes, no? Yes. Okay. Okay. So just in case you haven't, if statements are what make programs interesting. Well, if statements are part of something called control structure, and control structures are what make programs interesting. You could write, you know, this fantastic program, but if you don't have control structures, you don't have any way to control, like you don't have any way to have the program do different things when the user does different stuff. It has no way of responding to the user input. We'll kind of do with this line bit here, like this bit up here. But if we wanted the computer to do anything beyond just sort of drawing lines and squares and stuff where your mouse is, you need to start using control structures. Now, control structures are a much larger sort of collection of things than just if statements. And there are, and I see, yeah, MC story mode, so many ifs. That's the thing. A lot of times you introduce the if statement to somebody, and then everything becomes if this, 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 over and over and over and over again. Just pages and pages and pages and pages and pages and pages and pages of if statements, one right after the other, or like, you know, embedded within one another, because you can do that too. So there are more elegant ways to go about creating control structures than just if statements. But the if statement is certainly the easiest to understand introduction to control structures. So let's go ahead and we'll implement make a loop of a loop of a loop of a loop inside a forever loop. So a for deep nested loop inside of a forever loop. Yeah, it could be done. Which is pain. Of course, it's gotta be. It's gotta be. All right, so let's go ahead and let's take a look at the if statement, our first ever control structure. This is the structure of the if statement. If something inside of parentheses, and then generally curly brackets. Now, if the thing inside of the if statement is true, if it ends up being true, then the stuff inside of the curly brackets after the if statement will execute. If it is false, if it's not true, then it's just going to skip all of this code inside of here and then keep moving on. So that way we can have code that executes based on whether or not the user does a certain thing. In this case, we're going to ask whether or not they're holding down or pressing a button on the keyboard. Any button, doesn't matter, just has to be a button on the keyboard. Now processing already has something built in for that, which is pretty handy. It's called key press with a capital P. So if key pressed, and I believe we can actually just do that, but we'll use the full expression. Now equals true. So that's saying if a key is pressed. Now notice how I have two equal signs here. That is a thing about programming, because you only have so many, keys on the keyboard, and the computer needs to be able to differentiate between all of them in order to understand, because again, computers are dumb. When you do math, you say like if a equals 6, and you can understand that because of context. We have this if here, which changes the nature of that equal sign. So we know in this case, we're not saying that a is equal to 6, we're asking if a is equal to 6. However, because we're getting there. Because computers are dumb, hey, no worries. I understand that, Tim. See you later. We'll see you on Wednesday. Now, because computers are dumb, and we already have the equal sign reserved for something else, and that is, in this case, saying that a is equal to 6. We need to have some different kind of expression to ask if a is equal to 6. So in that case, we use two equal signs, because that is right next to each other with no space. Because that is, as far as the computer is concerned, a different sign than just a single equal sign. Oh, that is a very pink color. All right, well, we'll do that in a moment. We'll get the if statement done first, and then we'll put in your nice pink color. So that's why you have the double equal sign there. That is a very necessary thing. I do, but one of them isn't working. Why is that? Is it coming up funky? Okay, good. Okay, fair enough. It was just the fact that two separate people asked me if I had dual monitors at the same time. That was nice timing, you guys. So what we're going to do is we're going to draw a circle. It's called an ellipse, but we can set it up so that the ellipse is actually like a circle. So if key pressed is equal to true, draw an ellipse at 100, 900, and it's going to have a width of 100 and a height of 100. So it's going to be a perfect circle as far as a computer can draw. And let's just go ahead and you guys can thank Gavin for this one. We'll keep it as a surprise. So now we got the lines drawing and everything like that. If I hit a key on the keyboard, look at that. That circle appears there. Yeah, sure. Let me just go ahead and click and oh, yeah, whoa. That is a serious color. Okay. Yeah, sure. Good Lord. That's what we just added right there. Una. Una? Una? Yeah, no worries. That was searing. Business calls. I too have that issue all of the time. All right, so that's pretty much the code we're going to get through today. It was a little bit of a slow start because there was, I mean, I like the fact that you guys talk. That is, this from Europe. That doesn't really sound like a business call unless you're, you know, big time. Yeah, well, okay, as long as that's cool. It's not drawing the circle when you press a key. Why don't you go ahead and show me that bit of code that should draw the circle, and let's see what's going on with that. Let's go ahead and copy paste it into there. Okay, so it totally should be. Where is that in your code? Is it inside of your void draw? Why don't you just copy paste your whole code into there? And for everybody else, I'm going to go ahead and ask the poll questions, and we're going to call it a few minutes early. Like I said, I know we didn't make a whole lot of progress today. Most of that was just me catching up and sort of doing the interesting. I do have a cat. Anyway, just mostly playing catch up. Key pressed equals true. Let's just go ahead and do it like this. Interesting. Interesting indeed. That should be. Now, the first time you copy pasted it. Oh, Gavin, you don't have a semicolon after your ellipsis draw, and Paula. I do not have a dog now. Paula, it looks okay. I kind of wonder why that's happening, though. I'm not really sure. So it just nothing appears on the screen, like no circle or anything like that when you press a key on the keyboard. Sorry, Paula. Oh, gotcha. Yeah, no worries. I'm glad it works though. I was gonna say that was very strange. Oh, I forgot I did that. And Gavin, I was saying that there was a semicolon after your ellipsis. All right, poll questions incoming. The best opinion, and then. All right, we're at 73%. Let's see if we can get a couple more people. Generally, I wait for like 80% response and then start counting down. If you get 100%, I just close it. All right, 82. So 5, 4, 3, 2, 1. Close. All right, so we got a couple of people who thought it could have gone faster, but on the whole, it was pretty good. All right, that's fine. That's fine. I know I was, whoops. I know I was sort of all over the place today. And what did you think of this topic? Well, let's do this one. The self-conscious one. Are you all right? 80%. So 5, 4, 3, 2, 1. Close. All right, and I'm glad that today went pretty well. As far as introductions go, it could have gone a lot worse. But anyway, with that, if you guys have any questions, I usually hang out for a few minutes after the class, answer any questions that you guys have. Otherwise, you guys are more than welcome to head out and have a wonderful couple of days, and we'll see you on Wednesday. All right, I got a couple of things that popped up. Not as well as you usually do. Yeah. Well, I appreciate it. That's actually very nice. Thank you. Hopefully, we can keep things as interesting and enjoyable. PC, Samuel. No problem, Abigail. Have a good one. See you later, Cameron. See you later, Paula. And are you running into an issue with yours, Liam? All right, later, Sam. Oh, it's not working. Okay, I see that up there. All right, what we got? What we got? Let's see. Resize the question box.